Hey guys, welcome to this Wintellect webinar. Today we're going to be talking about hot path and cold path on data paths on Azure specifically. I'm not going to have a lot of slides. I just do want to do a kind of an introduction to this idea and then look at Azure technologies as it relates to what cold path and hot path are. And I'm going to have a demo where I have a lot of these technologies implemented to show you kind of how this would shape out if you were to do something on Azure. But a little bit about who I am. I'm Blaze Stewart. I'm an architect at Atmosera, and I'm a Microsoft Azure MVP. I've spent most of my time working in the Azure space. So I've been doing Azure for probably, 10 years now, and very actively for the last 6 or so. And so I've been very much a part of everything Azure, and I have been doing a lot of webinars and content development related to it as well. So a little bit about who we are at Atmosera. Let me click the slide here. Atmosera, just a little bit about who we are. Atmosera is now a merger of who I came from, which is Wintellect, and then the Atmosera folks who ran an MSP business for doing managed services on Azure and a cloud service provider on Azure. And then Wintellect was a premier partner in the Microsoft space for doing consulting around Azure and app dev. So we did a lot of stuff related to what Atmosera did on the managed service side on the Azure space. So the two companies coming together offers a full suite of services relating to consulting services, training services, all in the Azure development space and the Microsoft stack, and then managed services for managing your workloads on Azure as well. So basically everything about us centers around the Azure workspace somehow. So that's who we are. Let's go right into what we're going to be talking about today. I'm not going to spend a lot of time on, as I said, I'm not going to spend a lot of time on slides, but I do want to talk about Azure data reference architecture for all things related to how data is going to flow once you get it onto Azure. And I'm going to talk about this through cold path, hot path, and something called warm path, which hopefully this will help inform your decision making around all things Azure whenever you get to putting your data out there and you're just like, how in the world do I use Azure to process and collate and do all this stuff related to data? So that's kind of the crux of what this is going to be getting at. So ultimately, everything on data starts with some kind of data producer. Now, this could be anything. I don't know. It could be apps. It could be Azure IoT, Azure Sphere, SDKs, agents, whatever. You have something that is creating data, and that data needs to be, stored in the cloud. Now, I'm not going to get into the weeds on how this data gets from the producer, which could be a browser, it could be a mobile app, it could be IoT data, it could be any number of things that are just producing, collecting data, and then processing that in a local context, and then taking that data and shipping it to the cloud somehow. It could be through HTTP, through some messaging service, whatever it might be. But ultimately, it lands in something on the cloud. It could be a web app, it could be just an endpoint for an IoT device, anything like that. But we end up with something that gets that data. It receives that data and then either stores it or forwards it, or both. And that's what we're going to be talking about as a receiver. Now, typically on a data path, that's going to be some kind of data storage mechanism. Now, the data storage mechanism in Azure for just landing data is typically going to be either a message service of some kind, or it's going to be some kind of data storage service like a storage account. So the two that I have here, I have a couple of them listed here that are going to be useful for landing data. Now, this data can also be landed in like a database, but typically for data, flows where we have data that's going to be processed, we typically land the data as it's received. So we don't really do any kind of data processing on there. We just take the data as it was sent and we put it onto an event hub, which could be just for real-time processing, or we can land it in a storage account, put it on a service bus, or if it's Azure IoT, you can put it on an IoT hub, which is really just using some implementation of service bus under the hood. And So whatever it might be, we're going to be landing that in some kind of message retention system that ultimately is going to store it either temporarily or persist it for some length of time. Now, that length of time, depending on what path we choose, could be seconds, or it could be days, months, years, even depending on whatever the retention policy of that is. Now, typically, that retention policy is going to be configured, and you're going to be choosing some kind of storage mechanism for that appropriate storage retention policy. So if it's short-term Event Hub, of course, that's going to be the one you're going to choose, because that's going to only retain messages for the duration, usually no more than a day. A storage account can do it indefinitely. You can have it out there for years even. And Service Bus, typically around a week, but typically no more than 30 days. And IoT Hub is similar to that, where it's not long-term retention. But ultimately, you're going to do some kind of store and forward mechanism. Regardless of however you land that data, you're going to have something to receive that data. You're going to store it in some way. So now I actually want to talk about the various paths your data can take on Azure. So with Azure IoT and Azure data paths and whatever it might be, really what we're talking about is some kind of data processing path. Now, we're not talking about just an API where it's, we get the data and we, land it in a database and that's it. And, that might work for more monolithic applications, but this is really not thinking about it in those terms. However, you can incorporate some aspects of that into data paths as we see here. So your data receiver might be an app, and your data store, your long-term data store, actually might be some kind of database. But typically, for more scalable architectures, that's not really what we're going to try and do. We're probably just going to land the data, and then we're going to ultimately do some kind of more permanent storage, depending on whatever our context might be. So the difference between what we call hot path and cold path really depends on how quickly we want to make the data available for consumption. So hot path is fast, and cold path is, generally speaking, going to be slower. So this one, we typically think of this as real-time data processing. And so this is going to be more event-driven data processing. So as soon as this device over here, whatever it might be, a phone, a sensor, a web app, whatever it might be, sends a message over to a receiver, it just forwards it onto a hot path, and then as soon as it's received, it lands on the hot path. This processes it in real time, and then it puts it out to something on to the right side here, which we'll talk about in just a minute. And so this happens very quickly, usually instantaneously from the time it was sent into the time it's actually presented for use. And so this is going to be very much event-driven, very much small packets of data that are going to be more message-oriented. So we're talking a device has some kind of message that it generates, telemetry, whatever it might be. It's transactional in nature. It gets shipped off to the web, to the cloud. The cloud receives it. It puts it onto the hot path. The hot path processes that, and that process is then going to do something to it. It's going to be more than just receive it as is. It's going to filter the data. It's going to enrich the data. It's going to do stuff to that data that's going to do some kind of transformation to it beyond what it was in its received state. That's really what hot path is trying to do, is just do that real-time data enhancement, enrichment, and filtering in one of these various services so that it is more than what you actually received. So that is typically going to be data enrichment in most cases, or data filtering. So it's going to be joining it with other data sources, or it might be filtering out noise that is going to be downstream of this. So it just might be looking for certain kinds of data, and then basically dropping everything else, so it only forwards what it needs to forward and not have a bunch of noise. And this the services that support this are varied. On Azure, there's a ton of these. The one that I'm going to look at today is Stream Analytics, because it's a platform as a service, and it's actually really easy to use. I like it because it just makes doing a lot of this real-time real-time data processing very simple and very scalable without a lot of fuss on Azure. You don't have to have deep knowledge of any of these other technologies in order to make Stream Analytics to do a lot of cool stuff. And we'll look at that when we do our demo. You can do some stuff with event hubs. I know I mentioned that over here. There's some stuff that you can do in the context of that. Service Bus has the ability to do some of this as well built in. It can do filtering, and it can also do data enrichment some, but it doesn't have the ability to do joins. But you can do message manipulation if you do with things like topics and queues. There's certainly things you can do on Service Bus that are beyond just some of the basics that you wouldn't be able to do just by getting a message and doing nothing else with it. And of course, with other services like Synapse, Kafka, and Databricks, these require deep knowledge to use them, because they're not just something that you can turn on and instantly have something up and running in a matter of seconds that can do stream processing, but these are very programmable, so you have a lot more control on these offerings right here on Azure. But they do have a lot more uptake on learning them. So a steeper learning curve, but very powerful tools for doing stream analytics. And they also do some of the other workloads that we're going to be talking about when we talk about ColdPath or what have you. But Stream Analytics is the one I prefer. If it doesn't work, then of course you can go to another one, but this is the one I'm going to be demoing today. So HotPath, as I said, is for real-time data processing. I do want to look at ColdPath, which is kind of the flip side of this. And fundamentally, ColdPath is something like what we might call batch processing. So this one is what we real-time event-driven. This one is batch processing. So this one happens on some kind of trigger, typically time-bound. So it happens every hour, every 15 minutes, whatever the time box is for this particular one. But instead of processing single messages at a time like HotPath does in real time, this one is going to have a longer latency between when a message is received and the time it shows up in whatever is going to be consuming it. So this one is going to batch up a bunch of messages, a bunch of data, and it's going to process this typically on a cluster, and it's going to take a long time to do it. This one only takes milliseconds to do it. This one's probably going to take some significant amount of compute and time resources to process typically thousands or millions of data points that are coming into one of these receivers over here. So typically what happens in this case right here is messages are received and they're stored in some kind of permanent, persistent storage, not on a service bus or an event hub where it's the expectation is it'll be picked up rather quickly. Rather, it's stored in something that's more persistent, like a storage account or a file share or a database. Most of the time, whenever I'm using this, I will store it. I'll land it in a storage account of some kind. Just take the message as is. It either ends up in a blob storage, or you can use data lakes, which are supported by storage accounts. And it's just landed as it was received. It might tag it with some additional data like time received, and there might be some other metadata that gets associated with it. But by and large, the data is not manipulated. It's just stored as it was received, and then something comes along later and picks that data up and processes it using some kind of batch processor. So that batch processor then is going to do all the same kinds of stuff that this one does, but it's going to do it in bulk over a long period of time for processing it. And so it's going to do data filtering, data transformations, data enrichment. It's going to do joining data. It's going to be filtering out data. It's going to be doing all that kind of stuff that data processing does in a batch style. And there's a lot of different technologies you can do that with on Azure. Now, typically, it's going to be data lake is where things are going to be stored, or storage accounts, or what have you. But the compute that's going to be doing a lot of this would be something like Data Factory. Data Factory is one of the main ones that I like to use, just because it's pretty straightforward. It's easy to use. There's not a lot of fuss involved with Data Factory, and you can create these workflows in Data Factory using a visual designer, and the visual designer allows you to builds a data flow, and then you can use some orchestration around that, and then you can set these up to run on batches. And I'm going to show you Data Factory in my demo, but You can also use Synapse, which has a lot of the same plumbing built into it that Data Factory has for doing batch processing. So a lot of the same kinds of things you can do in Data Factory, Synapse supports. Then, of course, Databricks is another one of those that you can use for batch processing if you like that ecosystem. Databricks has a lot of tools and a lot more control over the data itself. So you can bring a lot of different languages, programming languages to Databricks, including Java. You can do Python. It's got its own SQL-like language for doing data processing. You can also bring containers into Databricks, but it basically gives you a compute platform that will have a lot of connectors into it that allow you to apply just straight up code to it, and then you can process it in batch using highly scalable compute, and then do many of the same things like you could do with Data Factory and write that data out to some other kind of persistent storage, now in a more scrubbed state. So typically something that's going to be more oriented for consumption, whatever is going to be consuming that. And of course, there's Azure Database as a Service. So that would be anything like Azure SQL, Cosmos DB, any of the open source databases like Postgre or Maria or MySQL. And of course, there's Azure Batch, which is just VM orchestration, where you can then take whatever you want to put it on a VM and process it using the Azure Batch orchestration tools that it provides. Now, I typically go for Data Factory just because it's simple. And if it doesn't work, of course, then you can use one of these other options. Either Synapse or Databricks would be my second or third choice. And then Batch or one of these things using stored procedures or something like that for a third or fourth choice. But any of these would work for that. And of course, that the cost mechanisms are also going to look different in that. But once you have that data process, you've done the transforms, you've done all that batch processing, then you forward that out to something that's going to be ready for consumption. Now, again, the key differentiator here is this one is long. This one is doing bulk processing against large data sets where the need to consume that data is not instantaneous, while this one is more instantaneous. I need it as soon as I receive it or pretty close to the time it was received, usually seconds later from when it was landed. And this one could be, any time window greater than real time. So it could be 5 minutes, it could be 15 minutes, an hour, daily, weekly, whatever the requirements drive it, but it's more that, I can wait for the results as well. There is another one that's in between this one that a lot of folks like to mention, and it's called WarmPath. Now, WarmPath on Azure is something that is kind of like ColdPath in that it's batch oriented, but it's batch oriented. I know that this webinar was about cold and hot, but it is small. It is batch oriented like ColdPath, but the time box on this one is typically what you might get with HotPath. So this one is typically going to be near real time or almost real time processing. So small windows, maybe around a minute, 5-minute windows, typically using the same kind of technologies you'd find in ColdPath like Data Factory, Synapse Databricks, but it's going to be doing it on a much tighter cadence. So it's going to be processing probably hundreds or thousands of messages versus thousands to millions of messages like down here. But this one has a little bit of overlap with what you would expect to see in terms of the style of processing. So it looks kind of like a hybrid between HotPath and ColdPath, and it uses a lot of the same technologies. So again, you can use a data lake in this one for, you read it out of persistent, but you can use Data Factory. You can use Databricks and Synapse any of these more cold oriented ones, but you could also use functions too. So functions can respond to you can use functions up here in HotPath. I don't think I included. I did put functions right there. It is. Service bus and functions. Functions would be a good one for this one right here. If you wanted to fire those on a tight interval, like every 5 minutes, you could do a time-based function to do that, to do these small batch oriented processes. And this one will still get you the same kind of results that a HotPath or a ColdPath will get. It's just going to be doing it much quicker, and you're going to be processing it much tighter windows. So kind of a hybrid approach to these. And I've seen this come up in recent conversations, but it just has the feel of ColdPath in its style, but it's orientation is more real-time or near real-time processing, what you would expect from hot path consumption. So that is really kind of the two paths that we're going to be looking at here, is hot path and cold path in our demo. But the warm path is just one that you sometimes hear folks talk about. Now, ultimately, this all gets put out in some kind of presentation, and this is the consumption of the data. So if it's hot path, the consumption could be cold path storage. So in other words, I need the data to be stored. I need to be processed quickly, but stored so that an API is going to have the latest and greatest data that is up to date in real time. Now, it could be an API that's consuming that data. So even though you process it in real time, it might not be consumed for some time down the road. So it might land in a database, seconds within receiving whatever the producer produced, but the API that's consuming that might not read it till an hour or 5 minutes later. But it can also be used for a push style architecture over here, where you might have something that's kind of over here to the right of this, where the presentation is receiving the output from this and then forwarding it on to something that's external. And so this would be something like, I'm going to land this into a service bus. There's something iterating on that, maybe like a function, and then that's just forwarding it on through to a webhook or something like that. Or maybe it's landing it into a database. I don't know. But the output of this is really the presentation of it. It's whatever the consumer is going to be seeing once the data has been processed, either in a hot, warm, or cold path. And that could be an API. It could be just a data set that you're exposing as a data endpoint, or it could be some kind of reporting. And there's a lot of different technologies that support this presentation of data once it's been processed. And of course, there's all the database service as an offering. That'd be Cosmos, SQL Server, Maria, Postgres, MySQL, what have you. And then of course, Power BI, if you want to use that for reporting and dashboarding and that kind of thing. Azure Synapse gives you data warehousing functionality if you want to use that for reporting and for that OLAP type processing, if you want to do multi-dimensional analysis of data versus a database like OLTP, which you get from database as a service. Of course, Azure Functions can do a lot of this. Like I mentioned, you can use like a service bus and a function, and then call a webhook externally to forward the data onto something outside the cloud, or the functions could serve as APIs. And of course, Azure App Services can be a front end for a database. And so you could write Azure App Services, expose that through an API, and then the API then is consumed by mobile applications or through dashboards or through web apps, whatever it might be. So however you serve this data up, it's basically the output from whatever your data paths are going to be doing. Once the data is received, it processes it using one of these paths. It puts it in some sort of presentation, and then ultimately you have some kind of consumer of that data, which is external systems, reports, some kind of reports, consumers, data integrations, whatever it might be. This is really off the cloud, and this right over here is off the cloud. Everything kind of here in the middle is really what you're going to be doing on Azure. And so this is your Azure, data pipelines right here. You have, receivers, your data pipelines, and then your presentations. And then over here, you have the consumers of that data, which would be, something that isn't on the cloud. That's, apps, mobile apps, reports, some kind of external consumer, data, webhooks, whatever it might be. There's a lot of those. And the style of how it consumes those, it could be request response, like what you do with HTTP, or it could be a push from the cloud, or it could be something else like an FTP download or whatever. It doesn't really matter. It's just something that's going out here to this presentation, grabbing data, and then consuming it in its own context. But we're mostly concerned about this stuff right here. And that's what I want to demo today. So I know that's a lot to kind of take in, but I hopefully that some of this will crystallize as we look at this through the context of a demonstration, which I want to talk about now. So once we have the demo architecture right here kind of outlined, I'm going to go over to the Azure portal and show you how I glued all this together. And it's actually really easy to do. I think I set this whole thing up in maybe less than an hour. one beginning to end. So this is what my demo architecture is looking like. So I'm using a producer. I'm using pfSense, which is a firewall. So basically what my producer is going to be doing is producing firewall events. So anything that happens on my firewall, I want it to show up in Azure. So to do that, I needed to create some kind of syslog. And so what I did is I just wrote a little app, a little 50 lines of code that basically acts as a syslog server. So when something happens on this pfSense law box here, my firewall, it reports it out to a syslog server. Now this syslog server receives that event and it just turns around and forwards it back to the cloud. And so this is where it gets onto Azure. And so I'm using an event hub. So my event hub is receiving the output from the syslog. So this basically just creates an event, syslog picks it up, and then forwards it onto Event Hub. Now, Event Hub is a very useful tool for receiving these kinds of messages. It can receive dozens and millions of messages really per second. It's highly scalable. So it's really, if you're wanting to build highly scalable messaging infrastructure for receiving just tons and tons of data, Event Hub is the really kind of the go-to option for that. Now, once it's on Event Hub is going to want to get rid of it as quickly as possible because it's really not designed for long-term storage on Event Hub. So it's going to throw it over to something. It really just wants to get rid of it as quickly as it receives it. It'll retain it for a little while, but it's really not considered a long-term storage option. So in my case, I want to process that data kind of in real time. So I'm going to use Stream Analytics. So basically, after I land the data, Event Hub gets it and forwards it onto Stream Analytics. And and then Stream Analytics has all the plumbing needed to bolt up to an Event Hub. And it just receives the message and then it processes it. And this uses some SQL-like language where it allows you to do some data enhancement and data enrichment and joins and transforms on it inside the context of Stream Analytics. And then Stream Analytics, because it too is a streaming processor, does not store data. It wants to get rid of it as soon as it receives it. And so again, event-driven architecture here. Stream Analytics processes it, and as soon as it's done with the results, it's going to hand it off to something else. In this case, I'm going to be using Service Bus. So Service Bus has a little bit better, has long-term message retention than what you would get with Event Hub or Stream Analytics, but it's generally considered not a long-term storage platform for messaging. I mean, yeah, you can do long-term message processing on Event Hub Service Bus. I mean, I think you can get up to, I think you can configure up to 30 days or something like that. But the idea behind this one is that you don't really want to store things here indefinitely. It's not persistent storage. It'll store it for a while. If you have a network outage, it will continue to accumulate messages until whatever is going to be receiving those messages comes back online and starts receiving those messages again. But it's designed to keep messages around for a temporary finite amount of time, and then something is going to then consume that, which in my case I'm going to be using an app called Service Bus Explorer, which is basically just an app that allows you to configure and monitor and program and do a lot of different stuff in the context of Service Bus just using a desktop application. So that's what I'm going to be using to demo all this. So basically, as soon as the message emits, by the time it emits from here to the time it shows up in Service Bus Explorer, it's a matter of seconds. I mean, it doesn't take long for this whole thing to happen. And so I can basically generate the message and get it in Service Bus Explorer within less than 2 seconds usually from the time that it's emitted to the time it shows up over here. So that's my real time, that's my hot path, that's my speed path, that's my speed layer. Now to demo a cold path, I'm going to take advantage of a feature that is built into Event Hubs. So rather than having to write the data twice from this app right here, Event Hub can record data into a storage account. So basically, as it's received into the Event Hub, it can write to a storage account. And this allows me to persist the messages in persistent storage. So it'll basically batch them up by whatever time window you want. I think I specified mine at 5-minute intervals. Over a 5-minute time period, it'll batch those messages up, and then it writes them to a storage account as a data file. And then that storage account then will persist them for as long as I need them to. It's disk storage, so I mean, as long as I keep that disk storage around, it's going to stay there. I can set up retention policies and do a lot of cool stuff with that, but that's within the context of storage accounts. But I really just want to keep it there until I process it. which in my case is going to be done with Data Factory. And so what Data Factory is going to do is basically, this is going to write data in a 5-minute interval. It's going to write a file, and then Data Factory is going to pick that file up and process it. So I have this one configured to run every hour. So basically, this is going to look at the last hour's worth of data, and it's going to process it. And then it's going to be able to read the output from Event Hub's storage account. It's going to pick up all that data, process it in batch over some period of time. I think it takes about 5 minutes or whatever it is to process the data. And then after that, it's going to write it to a SQL database. So in this case, the data is going to land in a SQL database that I can then use for consumption. And that is going to be how I present the data for consumption. In my case, I'm going to use SQL Server Management Studio as the client that's going to be basically going to be able to allow me to log into this database and query it. So all this infrastructure to wire it all up and to just make it all work took me, I don't think it took me more than an hour to do it. Most of the time was just configuring the Data Factory. I think was the longest one to set up and configure, but generally speaking, I think this one took me about 10 minutes to write the code to do that, and it took me about 10 minutes to wire all this up, and took me about I don't know, maybe about 30 minutes to wire all this up. It didn't take very long to do any of this at all. So once I had it all wired up, I had two hot paths. Two different data paths on Azure, which in the context of this is really everything right here, up and running. And this is two different data paths sourced from the same data, but two different styles of data processing. One of them is real-time event-driven data, and the other one is more batch-oriented, which is a cold path style of data architecture. So let's go over to the Azure portal and take a look at what this is going to look like in as it's working. So let me pull this up right here, and this is Azure. This is the Azure portal, and I have this resource group called Hot Cold Demo. And these are the resources I just showed you. So I'm going to show you the hot path first. Before I do that though, let me show you the code, kind of what this looks like on the other on premise, which is really where I'm sitting in my office. And I have my firewall behind me, and I have my my syslog code running right here. And this is the actual code that I wrote to do this syslog thing. It's just a little Node.js app that receives the events, and I configured my firewall. It receives an event and basically just does some data enrichment right here. It's just extracting the message, the fields from the actual message, and then it's putting onto an event hub. But doing a batch, and then every 100 milliseconds, it just checks to see if there's something on this event array, and then it batches it up and sends it up to an event hub, which is right here. So I can use that to, for my demo purposes right here. You can see this access key right here, but as soon as this webinar is done, this is going away. So, you won't be able to use this. So in any case, this is what this is looking for. It's very simple code, and I have it running on this box that we're looking at right here. If I minimize, let me maximize this window right here. And this is the events that you see running right here. It's just processing these events as they come in. It's not a lot of data, but it is producing a couple thousand messages per hour, which is enough to demonstrate this. So you can see the messages are flowing in from my firewall into the syslog, and then this is just basically taking them and putting them on Event Hub. So very simple, very easy to set that up. I didn't spend a lot of time trying to figure all this out. So once that's there, what I now can do is process this data in the cloud. So for this particular demo, I, again, have an event hub that all this data is coming into. And this one is just using a simple event hub. I have a single event hub that is basically fielding all this data, and then it's taking all this data and doing something with it. It's doing two things. As I mentioned, it is forwarding it on to a Stream Analytics processor, but it is also capturing the data to store it. And so to capture the data, I've configured this right here on a 5-minute interval. It's basically just creating data into a storage account. So it batches it up on a 5-minute interval. I can slide this up to 1, or I can go up to 15 minutes. But in any case, I can basically batch all this up and send it off to a storage account, which this one right here is doing that. You can configure it for a data lake, or you can use a storage account, which storage account V2 supports data lakes as well. And this is just basically the folder structure that it's using. And it's just, basically creating a folder that is as using a date structure for the folder structure, and then it's dropping a data file out there to consume. So once I have that data stored, I can use that for cold processing. But for real-time analytics, I'm using a stream processor, which is Stream Analytics. So the Event Hub, it's basically just there to receive the data from the syslog server. Now, if I was using something else like a mobile app, or I was using something like IoT, I would use IoT Hub to do a lot of the same kind of stuff to receive the messages. Or if it was a mobile app, I might have an API. But fundamentally, the idea of landing the data like this is something that's very common in data paths on Azure. So if I was writing an API, I would still land the data pretty much as is in some kind of data storage mechanism before I process it. And the storage accounts just work really, really well for that. That allows me to do a lot of things like replay the data, or if I have data corruption in the database, I can say, okay, what did the original data look like? And I can debug things and do a lot of things like that. It's just a kind of a safety net for being able to keep the data as it was received if I need to go back and replay it or debug or look at historical reasons or things like that. But once I have it on the cloud and I have it in my Stream Analytics, I can then process it here. So Stream Analytics is the next step in the hot path. And this is really easy to wire up too. I basically with a Stream Analytics job, I wire up an input and output, and then I do a query. And then my query is very simple. So my input is my Event Hub, and that's what I have wired up right here. This is just pointing to that Event Hub that receives the data. And my output, in my case, is just a service bus. So it's a service bus queue that I configured as the output for this. So it processes the message and then writes it out to a service bus queue. And so this is configuring inputs and outputs. And then the query is very straightforward. It's a SQL-like query. Now, of course, this is a trivial demo, so it's not intended to show, the scope and scale of what you can do with this query language, but it's pretty powerful. So some of these other inputs and outputs that you can have can be, it can be long-term storage, such as a SQL database, or it can be something that's more message-oriented, like a service bus. And inputs themselves can be multifaceted as well. I can have more than one Event Hub, for instance, feeding data into this, or I can enrich data from what we might call dimensional data, which is things. If I have a code that comes in on this and I want to enrich the data with data about what that code represents, I can do that. So I can join the data coming into the Event Hub using this. I can configure an input and then join it using this SQL-like language to enrich the data as it flows through this Stream Analytics. So all of that is possible within the context of Stream Analytics. It's very, very robust. It's very powerful, but with more complexity comes more compute, and with more compute comes more costs associated with this. This is very simple. It's just basically a filter. I'm excluding data based on a filter. I'm basically looking at the tag, which is this filter tag is what I'm interested in. That's just basically a firewall event that excludes anything that's not a firewall event. So that's like if my firewall reports something like someone was logged into the firewall to configure it, that shows up as an event. I'm not interested in that event for this particular workload. I could have a different workload for that if I wanted to, but for this one, I'm just interested in firewall events, which is tagged with this filter right here. And that filters out the data, and then it allows me to just focus in on that. So once I have my Stream Analytics working right here, I put it onto a service bus. It filters the data. It writes it out to a service bus queue. And my service bus queue then receives the data, and it just goes into this queue right here, firewall events. And currently, it's not. There's no message in there because I'm basically, as these come in, I'm receiving them. So I have a listener currently right here that as the data comes in, it basically just goes out the door to the receiver, which is my case is Service Bus Explorer. So this one is receiving messages from Stream Analytics, receives it, puts it on the queue. Then there's something on the other end of the queue that receives it. It's not really doing any processing in this. So again, it's just basically in and out without any processing on this. But this will allow me to queue messages up in the event that I was to turn off my receiver, it would basically keep them up in the queue until I turn the receiver back on and it starts processing those messages again. So my receiver, again, is running on my desktop right here, and I'm just running something called Service Bus Explorer, which is just a simple desktop app that allows me to receive messages. And I have this listener set up right here, and you can see that I've had it running for better part of a day now, and it's just receiving messages, and each message gets populated and then gets added to the list right here, and it's I got several thousand in here as I've been processing this over the last few days, or last day or so since I set all this up. And it's basically just the firewall events. So if I wanted to make this more intelligent, I could build dashboards around this data, where I wanted to know, okay, I want to be alerted or what have you. But this one is just receiving and logging the event in this memory table right here. And so it's really not doing anything with it, but it does allow me to have a client attached to my output here that is receiving these in real time. And that's really the key thing here. And it's doing this without, they're just received one. So it's just getting messages, and I'm able to see them coming into this at a pretty steady cadence. And that's really what this is all about. So let's go ahead and look at the cold path and what that looks like, which is a little bit more, I'd say more involved, but it really has a very similar feel where you have data processing and then output, and then it's something to receive it, to consume it, really. In this case, SQL Server Management Studio, but let's go look at this one. So again, the data does go into Event Hubs, and Event Hubs writes that to a blob storage account. So let's look at the output from that. That's a storage account right here. And if I go into the containers right here, I have this syslog right here, and this is just the log events as they come in. Come down here. I'm drilling down into these events, and I only have about an hour's worth of data in here because after an hour it moves it to a process folder. It's basically just moving the data around a little bit, and it's writing it as an Avro file, which is a data format that is useful for something like data lakes. It's a file format that's for data, tabular data, and it allows me to have tight compression, a lot of other advantages to it, but it's just a format that can be consumed inside of Data Lake or in Synapse or Databricks. It's just a file format that's useful for that kind of stuff. So that's how the data is landed, and you can see that I only have about an hour's worth of data. So these are 5-minute intervals, as the Stream Analytics is writing the Event Hub is writing that data out to this. It's accumulating about an hour's worth of data. Now, if I come back out here to this process data, I should have yesterday's data as well. 27 right here. I have data right here, and this is just process data that has already been shipped off because I've already processed it using my data factory. And that's how I'm able to differentiate between data that has been recently written and data that is new, is I basically just move it, or you can delete it, whatever. I'm just moving the data so I can have a kind of an archive of it. But in any case, that's what I'm doing here. Now, data factory is really what does all the heavy lifting here. It's just firing on a 1-hour interval. So if I come over here into my data factory, I'm going to show you the pipelines and the other kind of tools that this does. But, data factory is straightforward. It's not as powerful as something like Databricks or Synapse, but it does a lot of the same kind of things. So let's go over here to look at my monitoring here. You can see that this is firing every hour. On a pretty steady cadence. It takes about 5 minutes to process the data. And truthfully, that's really not, most of that is spinning up the cluster to process the data. So from the time it starts the cluster to actually process the data happens very quickly, because there's really not that much data to process. That happens, within seconds. This is really not I'm doing this more for demo purposes, but if you actually drill down into this, you can kind of see just how much time is spent processing data. It's 9 seconds, but it really was it took about 5 minutes to create the cluster, 9 seconds to process the data, and another few minutes to shut the cluster down. So I'm paying for a lot of compute time that I'm really not even using. But all that to say is I did this for more demo purposes, but in a real live context, you would probably have a lot more data than what this is doing. I could probably more reasonably do this with a function app, but I wanted to use Data Factory to show you this from a demo perspective. In any case, let's go look at the authoring and just to show you what the data pipelines look like. The data set, I basically have inputs and outputs for this. So the data flows is where I configure the data processing. So I basically create a data source, which in this case is the data, the storage account. So I look at the source option, just looking for Avro files. It reads those as Avro files. It recognizes them. That's because I configured the data source to be an Avro file in a storage account. This right here just parses the data. It takes the data and it's a little bit of transformations on it. This does some selects, basically flattens the data into a single table-like structure rather than having an object. And then this just writes it to a SQL table, and that's all it does. This is pretty straightforward. I'm not doing any processing on this. Nothing real substantive anyway. It's basically just taking the data, flattening it, and then writing it to a table so that I can query it using SQL Server Management Studio. So the output for this, as you can see, is Azure SQL. It's just a flat file, a flat table, in Azure SQL. With a data flow like this, you can have multiple outputs and multiple inputs as well. So these can be arbitrarily complex. There's a lot of different things you can do with a data flow like this. So you can have multiple inputs, multiple outputs, joins, transformations. There's all kinds of crazy stuff you can do with this. Databricks and Synapse can do the same kinds of things, but this is just a visual tool. You can build some really complex code in this and really complex transforms using this tool. And so once you have your data flow built, you basically use pipelines to orchestrate it all. So I drop the data flow on here. I wire up a trigger, and then I set my trigger to run every hour. This one I just have running 1 hour, runs on every hour on top of the hour. So basically looks at the last hour of data, processes that, and writes it into a SQL table. And my SQL table is, again, very elementary. I don't have but one table in my database. If I was doing a more real world oriented table, I would probably have a lot more data in this database rather than just the raw data. I'd probably have dimensions, but I would have a lot of dimensional data, but this one just has a single table in it. I'm using a serverless model here. So because this is not a highly utilized highly utilized database, it's not something that I really want to spend a lot of money on. So this one I think is usually, it's going to go around $3 or $4 a month to run this one. Because it's just not hitting it much. But in a real world context, you'd probably have a much more highly scalable database that you're going to have a lot more data being consumed from that database. So this is what this looks like. This is the output from it. This is SQL Server Management Studio. I have it all wired up right here. And if I deleted it, in my dev, but if I wanted to do a select from this, I can go right here, just do a select top 100 rows or 1,000 rows, and it's going to run that query. And now I have, you can see this is the data. There's some nulls in here because my cold path is actually writing data that is not, I'm not filtering the events on this one. So some of the events aren't the kind of events that I would have for just firewall events. So I'm not seeing any questions. So I'll just go ahead and give you the 10 minutes back. And if not, please feel free to reach out to me. At bstewart or blaze.stewart@atmosera.com, or you follow me on Twitter, or just reach out to the webinar organizer Rachel, and we'll see you hopefully on future Atmosera webinars.